Hello my dear children of class 11 science. Today again I welcome all of you through this mode of teaching that we are already doing, that is YouTube mode, and we do again continue with the chapter isothermal and adiabatic processes. Okay, now in today's class we start with the concept of molar specific heats of gases. Okay, now this topic is actually important, okay, when we actually deal in details about the isothermal process and adiabatic process. Okay, now to understand this concept, okay, let me just go back to class 10. In class 10, as you know, you have learned one of the chapter, calorimetry. Okay, in that particular chapter you learn as one of the topic as specific heat capacity. Yes, there is a topic you learn, specific heat capacity. You learn this as a topic in class 10. Now this specific heat capacity is also called as specific heat only. We simply call as what? Specific heat. So I am just using the word specific heat only. Or we also call this particular term as principal specific heat. Principal specific heat. Now when I use the word specific, this specific word is actually related with unit mass. This is related to what mass? Unit mass. Now as for the definition, as you know that specific heat capacity of any substance, now this is for any substance, not only gas, it can be of liquid, it can be solid and all, any substance. Okay, so specific heat capacity, or simply called as specific heat, is actually defined as the heat that is required. The specific heat capacity or principal heat capacity is actually defined as the heat, is defined as the what? Heat. This is as the heat required, heat energy required, okay, to increase, or we can use the word raise, increase or raise the temperature, raise the what? Temperature, raise the temperature of unit mass. So I am using the word unit mass, okay, of the substance. Unit mass of the what? Substance, any substance, okay, substance, by how much degree? 1 degree Celsius, or that is also equivalent to 1 Kelvin. Because children, you know that when for any substance, when there is an increase in temperature or rise in temperature or fall in temperature, equal rise in temperature in degree Celsius and equal rise in temperature in degree Kelvin. Okay, that means the rise in temperature, when you calculate in degree Celsius or Kelvin, that is always same. That's why if a substance temperature is to be raised by 1 degree Celsius or 1 Kelvin, how much amount of heat that is required to raise the temperature of unit mass? Unit means 1 mass of a substance. It can be 1 gram, it can be 1 kg and on. Then that particular term is called specific heat capacity, or simply called as specific heat, or we also call as principal specific heat of a substance. Now children, one point you need to keep in mind, this particular definition which I explained just now is actually sufficient for the solids and for liquids. But in case of gas, the rise in temperature can be done under two different conditions. That means for gases, just keep in mind this is for gases, the rise in temperature, rise in what? Temperature of gas can be done in how many ways? 2 ways. So one is keeping the volume constant, keeping the volume of the gas constant, keeping the volume of a what? Gas constant. And even the rise in temperature can be of a gas can be done by keeping the pressure constant, by keeping the pressure, okay, the pressure of a gas constant. That means for any gas, okay, the temperature can be raised, one by keeping the volume constant, another by keeping the pressure constant. And you know, keeping the volume constant means what we call as isochoric process, and keeping the pressure constant means we call as what? Isobaric process. Now under this case, there are two principal specific heat capacities, or simply called as specific heat of gas, that can be defined. So under this case, when this condition is followed for gases, okay, then there are two principal heat capacity, or we simply call it specific heat, can be defined for gases. So one is called specific heat at constant volume, and another is called specific heat or at constant pressure. Now this is for gas. So for gases we can define specific heat or principal specific heat in two different ways. One is specific heat at constant volume, another is specific heat at constant pressure. Now to know what is specific heat at constant volume and how to define specific heat at constant volume, let me just define now. Now children, in order to define specific heat at constant volume, okay, so let me take a gas. Okay, this is actually we are dealing for what? Gas. Suppose we have gas, and this gas I take as 1 gram of gas. Suppose how much gram of gas is there? 1 gram of gas. So 1 gram is the mass of the gas, and 1 gram is the unit mass of the gas. Okay, now in this gas, okay, we supply heat. So suppose you are supplying, say, heat Q. Q is the amount of heat that you are supplying. Okay, so Q is the amount of heat that you supplied, and due to this heat which you supplied to 1 gram of gas, if the temperature of this gas raised by, say, 1 degree Celsius, or that is equal to 1 Kelvin, then how much amount of heat that you supplied to this 1 gram of gas, keeping volume constant, keeping volume constant, without changing the volume of the gas. If you supply heat to the 1 gram of gas, so that due to that 1 gram heat, if temperature of the gas raised by 1 degree Celsius or 1 Kelvin, keeping the volume constant, then that particular heat that is required to raise the temperature of 1 gram of gas, okay, to raise the temperature by 1 degree Celsius by keeping a volume constant, is actually defined as specific heat at constant volume. Specific heat at constant volume. So children, remember this definition. Specific heat at constant volume is the amount of heat that is required to raise the temperature of 1 gram of gas. 1 gram of the gas through how much degree Celsius? 1 degree Celsius, 1 Kelvin, when the volume of the gas remain constant. Okay, and this specific heat capacity at constant volume is marked by small letter CB. So I'm marking with a symbol, and this small letter C, small letter, this is small letter C, and B, okay, capital B, okay, let me write capital B only, is the symbol we use for specific heat. Okay, this is the specific heat at constant volume. Constant volume. But children, remember this, when I use the word specific, means this is actually for what? 1 unit mass. This is for unit mass of the gas. That's why the unit mass we have taken as 1 gram of the gas. Okay, so this is the definition of specific capacity. Specific heat capacity we also call our specific heat at constant volume of the gas. Similarly, we can define specific heat at constant pressure. At constant pressure. So for the gas, again we can keep the pressure constant. So keeping the pressure of the gas constant, and if you take a gas, this is a gas, and how much mass? Again 1 gram mass of the gas. If I take 1 gram mass of the gas and I keep the pressure constant, pressure I'll keep constant? Pressure constant. And by keeping the pressure constant, that is under isobaric process, and when I supply heat, and this Q is the heat that you supplied to this 1 gram of gas, and due to this heat supplied to 1 gram of gas, by keeping the pressure constant, so that the temperature of the gas raised by 1 degree Celsius or 1 Kelvin, and that heat is required to raise the temperature of 1 gram of gas through 1 degree Celsius or 1 Kelvin, when the pressure constant is defined as specific heat at constant pressure. Defined as what? Specific heat at constant pressure. Okay, now this specific heat at constant pressure is also marked by small letter C and capital P. So I am using the symbol small letter C, capital P, as the symbol of specific heat at constant pressure. Okay, so for gas we define specific heat in two different ways. One at keeping constant volume constant, another keeping pressure constant. Keeping volume constant is called specific heat at constant volume. Keeping pressure constant is called specific heat at constant pressure. But this definition which I have explained is for 1 gram of the gas, that is for unit mass of the gas. But children, as you know, we are trying to define the term called molar specific heat of gas. Molar specific heat of a gas, and this can also be defined under two different conditions. One is at constant pressure and one is constant volume. Okay, but you know, when I use the word molar, this word molar is related to mole, the mole of the gas, and mole is also called gram molecules of gas. And mole is simply a number. Okay, mole is actually a number. Okay, but as you know, 1 mole of every gas is equals to 1 gram molecules of that gas. 1 mole of every gas is equals to 1 gram molecules of that gas. So children, if I take 1 mole of gas or 1 gram molecules of the gas instead of 1 gram of gas, only 1 gram of gas, then the specific heat of the gas that we define is called molar specific heat of a gas. So in the specific heat term, if I use the word molar, and this molar word is actually related to 1 mole or 1 gram molecules of the gas. That's why instead of taking 1 gram of gas, if we consider 1 gram molecules, or also called 1 mole of the gas, then the specific heat are simply called as molar specific heat of a gas. And children, you know very well that 1 mole of every gas, 1 mole of every gas is equivalent to the molecular weight of the gas in gram, because every gas has what molecular weight. Okay, so 1 mole of every gas is equals to molecular weight of that gas in what gram, and molecular weight is expressed by symbol m. So if m is the molecular weight of the gas, then we can write 1 mole of the gas is equals to m gram of the gas, where m is what molecular weight. Remember this part, molecular weight of a gas. Like for oxygen, the molecular weight of oxygen is how much? 32. So 1 mole of oxygen gas equals to 32 gram of oxygen gas. Okay, so remember this part of the relation which I have explained. Okay, and this is true for any gas, whether it is a real gas or whether it is a what gas? Ideal gas. So children, I can now define molar specific heat of a gas at constant volume. So for that, let me just take a gas, and this gas now I'll take as 1 mole of gas. So this is 1 mole of what? Gas. And I keep this gas at constant volume. Now I'll keep the volume of the gas constant. Volume what? Constant. Okay. Now I supply heat. I supply, say, heat energy to this gas. Now by supplying some amount of heat energy to this gas, 1 mole of gas, by keeping the volume of the gas constant, so that the temperature of the gas raised by, say, 1 degree Celsius or 1 Kelvin, then the amount of heat, see, try to understand this statement, the amount of heat required to raise the temperature 1 mole of gas, okay, through 1 degree Celsius or 1 Kelvin, when the volume of the gas remains constant, is called molar specific heat of a gas at constant volume. So this is the definition of molar specific heat of gas at constant volume. So this molar specific of gas at constant volume is also marked by symbol capital letter C and B. So children, no confusion out here with small letter CB and capital letter CB. Capital letter C with B means this is molar specific heat of a gas at constant volume. But as I know that 1 mole of every gas is equals to m gram molecules of the gas. Now m is the molecular weight of the gas. Okay, so molar specific heat at constant volume of the gas, that is CB, is also equals to m into C, small letter CB, because small letter CB is the specific heat, or his specific capacity, also called, or specific heat of gas for 1 gram of gas. This is for 1 gram of gas. But you know, for 1 mole of gas, how much gram is there? M gram is there. So I just multiply this small letter CB by m. That measure molar specific heat of gas at constant what? Volume. So capital CB equals to m small letter CB, and this m is actually called what? Molecular weight of the gas. Molecular weight of gas. Okay. Now this molar specific heat of gas can be even expressed by the unit. This can also expressed by the what? Unit. Now to understand the unit, let me just write it down. CB, specific heat of gas, unit can also be expressed by as, actually CB, if I write, it can be written as Q by m into delta T. See, if Q is the amount of heat energy supplied, if M is the mass of the gas and T is the rise in temperature, then Cv equals to Q by M delta T. We can write this way also. And Q is expressed by unit what? Joule. The SI unit of heat is what? Joule. And SI unit of mass is what? Kg. And SI unit of temperature is what? SI unit of temperature is Kelvin. So the unit of this Cb equals to Joule per kg per Kelvin. But we are actually trying to express the unit of what? Capital Cb. And this is for 1 mole of gas. So the unit can be expressed for what? As Joule per mole per Kelvin. So instead of kg, I write on mole, because we define this particular Cb for 1 mole of gas. Okay, 1 mole of gas. That's why the unit will be Joule per mole per Kelvin. So look at the unit of molar speed at constant volume, Joule per mole per Kelvin. Okay. Now similarly, we can define molar speed heat of gas at constant pressure. And children, molar speed heat of gas at constant pressure can also be defined in a similar manner as molar speed heat of gas at constant volume. So for this also, we take a gas and we take how much? 1 mole of gas. 1 mole of what? Gas. And we keep this gas at constant pressure. Now we keep the pressure constant. Pressure what? Constant. Now keep pressure constant means under which process this gas is heated, at under which process? Isobaric process. And when you supply heat, and say Q amount of heat that you supplied, and due to heat supplied to 1 mole of gas at constant pressure, the temperature of gas raised by 1 degree Celsius or 1 Kelvin. Then the amount of heat energy required to raise the temperature of 1 mole of gas by 1 degree Celsius or 1 Kelvin when the pressure remains constant is called molar specific heat of gas at constant pressure. And this is also symbolized later capital Cp. Okay, capital Cp. And this capital Cp is also written as capital M C small letter Cp, where M is the molecular weight of the gas in gram, where Cp is the specific heat of gas, and this is for 1 gram of gas, and this is for m gram of the gas. So Cp, capital Cp equals to capital M C small letter Cp, and this Cp is also expressed by the same unit, Joule per mole per Kelvin. So like sim A, like Cb is Joule per mole per Kelvin, and similarly Cp unit is also Joule per mole per Kelvin. So this is the SI unit of molar specific heat at constant volume. Okay, so I have explained in detail about the two specific heat for the gas which is at constant pressure and constant volume. Now in the next YouTube video you learn the relation between these two heat, what is Cp and Cp.